Okay, so yesterday we went over the test. Any lingering questions on that stuff? All right, so we're going to start right in on Unit 7. This is Unit 7 out of 8. And like I said, this one's really short. It's only 6 instruction days total. So the test will be really soon. But this unit deals with differential equations, more differential equations. So it's stuff we've talked about already, but just taking it a little bit further. Okay, so this is differential equations. And in particular, we're going to be talking about separation of variables. So normally, when we've talked about differential equations, it only contains one variable. Like, for example, if I had something like y dx equals 3x squared, right? So essentially what you're doing is you're like moving the dx over to this side. So you have dy equals 3x squared dx. And then you're integrating both sides. So the integral of dy, the integral of 1 is just y, right? And the integral of 3x squared dx would be 3x cubed over 3 plus c. So that's essentially what we're doing when you're solving a differential equation. You're separating the variables. You're putting everything that has a y in it on the left, which really is just the dy, and then you're putting everything that has an x in it on the right, including the dx. Okay? So if you have a differential equation that contains both x's and y's over here, you're going to do the same thing. You're going to move everything that has a y in it, including the dy, onto the left, and everything that has an x in it, including the dx, onto the right, and then do the same process. So for example, suppose the differential equation was like dy dx equals x over y. Okay, so here I could just kind of like cross multiply, sort of, and you get y dy equals x dx. Okay, so this step is to separate the variables. You want to keep everything that has a y in it on the left, and keep everything that has an x in it on the right. So separate the variables. I'm going to move all terms with y to the right, all terms with x to the left. Oh, other way around. Oops. Okay, yeah, left. Left. All terms with x to the right. Okay, now sometimes you might have a choice. Like, for example, don't write this in your notes, but for example, there might be like a 2 here, right? Well, if there was a 2 there, you could keep it with the x, or you could move it over with the y and write this as y over 2, right? There's an option. It actually doesn't matter which one of those options you choose, but my advice to you to make it easier, like later down the road in the problem, is to anything that you don't have to move to the left, don't move it to the left, because eventually we're going to be solving for y. And if you have extra terms on the left, like with the y, the integration is not going to be any more difficult, but your algebra is going to be harder in the end, solving for y. So anything that you can keep on the right that doesn't have a y in it, keep it on the right. it'll make your problem a lot easier to do. Okay, I'm going to erase that too. All right, so from here, everything's the same. You're just going to integrate both sides. Okay, so now on the right, instead of just getting y, you have y squared over 2. Right? Y squared over 2 plus c. Right? There's like a plus. I'm going to write c1 or something. Because then on the left, I'm also going to get x squared over 2 plus c. But this is a different c. But if you think about this, the C1 is just an arbitrary constant. It could be any number. C2 is an arbitrary constant. It could be any number. I could just combine them into 1, right? And just think of this as y squared over 2 equals x squared over 2 plus c. Like just combine them into 1. So it really doesn't matter if you have a c on the left and a c on the right. You can combine them into 1, but you have to have a c somewhere, okay? So if this is a free response question and you forget the plus c, it's minus 1 point, okay? And in other types of questions, it prevents you from getting even more points later because you have to solve for c or whatever. Like you normally have to find particular solutions in differential equations and solve for c. If you don't have the plus c there, then you miss out on all those points where you're solving for c and then getting the particular solution. Okay, so just be really careful about like following these steps. Okay, and then the last step is just to solve for y. Like I can solve this equation for y. I would multiply by 2, so I get y squared equals x squared plus c. Now you might be wondering, well, why didn't I distribute the 2 and write 2c? Well, c is just an arbitrary constant. So 2c would also be an arbitrary constant. It doesn't really matter. It just sort of is absorbed by the c. You could write 2c here if you want, but again, if you're finding a particular solution to this differential equation and solving for c, you're just making your algebra a little bit harder to do. Does everyone understand that? So yes, I'm multiplying this by 2, but you don't even have to show it there because it's just sort of another arbitrary constant. And then y would end up being plus or minus the square root of x squared plus c. So that's the solution to this differential equation, the general solution. Now let me write down the steps that I took. First, separate the variables. Okay. Second, integrate both sides. And you can combine the c's into 1 c. Okay, that's what I did in these 2 steps. And then in these 2 steps, I'm just solving for y. Okay, so this is the general solution to the differential equation. dy dx equals x over y. How do you check differential equations to see if they're right? The solutions to a differential equation? Yeah, you just take this derivative and make sure you get this. Now, you might be looking at this and saying, how is that derivative this? Let's try it. I mean, if I check this, check solution to a differential equation, just differentiate. So if I check this, so if y is plus or minus the square root of x squared plus c, then y prime would be plus or minus. This is something to the 1/2 power, so its derivative would be 1/2 of that stuff, x squared plus c, to the negative 1/2. X squared plus c to the negative 1/2 times 2x. Get that, correct? Well, look what happens. The 2 here cancels with that 2. And if you look at what this stuff is, right here, when it simplifies, this is really plus or minus x over x squared plus c to the 1/2. But this is x over plus or minus the square root of x squared plus c. It's x over y. So it checks out. Its derivative is, in fact, x over y. So that's the good part about a differential equation solution. You can always check to see if you're right, and you're 100% sure that you are if it works out. Okay? Let's try another one. With this one. If I have dy dx equals y squared times x minus 1. So step 1 is to separate the variables. So this is going to be separated as dy over y squared equals x minus 1 dx. So I just divided by y squared to get the y onto the left and then multiplied by dx. And notice I kept the plus 1 with the x. Partly because it's like a factor, and partly because I want to keep as much stuff as I can with the x. It makes it a little bit easier. Integrate. So on the left side, this is y to the negative 2. Its integral would be y to the negative 1 over negative 1. The integral of x plus 1 is x squared over 2 minus x plus c. Now just solve for y. So I can multiply by negative 1. So I get negative x squared over 2 plus x plus c. It's okay if I leave this plus c, right? Because c is just an arbitrary constant. If I multiply it by a negative, it's still just an arbitrary constant. Like absorbs all that stuff. So this is really 1 over y. So y would equal the reciprocal of this. 1 over negative x squared over 2 plus x plus c. That's the general solution to this differential equation. We okay with that? Let's do another one. How about this? What if I have dy dt equals y cosine t? I'll give you a second. Try and work that one out. Find the general solution to this differential equation. You need a little more time? Anyone? Okay. So separate the variables. So this would be dy over y equals cosine t dt. Then integrate. What's the integral on the left going to be? ln y. And on the right, sine t plus c. So then how can you solve for y? Yeah, y equals e to the sine t plus c. Now sometimes they'll take this type of expression and simplify it. They'll simplify it like this. They'll think of this as e to the sine t times e to the c, right? That's the same thing. When you multiply two exponentials with the same base, you add their exponents, right? But if c is just an arbitrary constant, then e to the c is an arbitrary constant. So sometimes they'll write this as c times e to the sine t. It makes the algebra easier. Again, if you're trying to solve for c, it makes it a lot easier if the c is here than if the c is up there. Okay, and if this was multiple choice, I guarantee you this is the way that they would want to write that. Does everybody understand that? Let's do another one. How about this one? Dy dx equals 2 radical x. Sorry, 2 radical y. I'll give you a minute. Okay, so I'm going to leave the 2 on the right, and I'm just going to divide by radical y. So this would be dy over radical y equals 2 dx. So on the left, this is really y to the negative half. So its integral is y to the 1/2 times 2 equals 2x plus c. Divide by 2, the y to the half equals x plus c. And then square both sides. So y would be x plus c squared. Now you can't just square the x and say x squared plus c. That's not equal to x plus c squared, right? So you can't do that. That's the answer right there. Is it making sense? It's pretty easy, right? Kind of the same thing that we've done. All right, one more. This would be the hardest one I can come up with. What makes it any more difficult looking at it now, though? But anyway, here we go. How about dy dx equals 4x cubed times y minus 4 squared. All right, so I have dy over y minus 4 squared equals 4x cubed dx. So when you integrate, this is going to be y minus 4 to the negative 1 over negative 1 equals 4x to the 4th over 4 plus c. Those cancel, so you have 1 over y minus 4 equals negative x to the 4th plus c. Then take the reciprocal of both sides. Y minus 4 equals 1 over x, negative x to the 4th plus c. And then add 4. So you get 1 over negative x to the 4th plus c plus 4. Everybody good? All right, so the homework tonight is on AP Classroom, actually. They didn't have a good section on this in Delta Math. So it's an AP Classroom, and it's just separable differential equations or something like that. I do have a problem of the day also. So, figure this one out. This one's not hard, I don't think. Do you have an idea? It's varied B, right? Everyone agree? If you have a rate function, f of t, it's the rate of evaporation, then the definite integral is the amount of evaporation over that time interval. So it's the amount of water, the total volume of water that evaporates from the pond between 4 and 10 minutes. That was an easy one, right? That's the thing, when you actually take a practice exam, like in its entirety, or the actual AP exam, you're going to notice that it's easier than the tests that we take in here, because the tests that we take in here, I try and come up with like the hardest questions I can because there's so few questions. But on the AP exam, there's going to be a lot of easy ones in there too. So you got to make sure you get all those easy ones right, and then you can kind of focus on the harder ones. Okay.
I don't know if it's going on. First place